So I got a little something to eat in me. And still got a sad face, but I guess you're in for a real treat, Internet. You're gonna watch me recode my TOML parser from scratch. So where are we here? We're in the source directory. So what I was trying to do before, when I nuked all my code, was just make this directory TOML parser. And I guess for the moment, I will. This is going to be a library, but for now, I'll just put in this entry point. Doubt this stream is going to go very much better. It's I kind of burnt my dinner. That was after deleting my code. So this is probably a fool's errand. But there you go. So just do that. That means we'll need to make that main. Oops. So there's that. And let's also so let's just do that. I'm still in my virtual environment here. Although once again, I'm in the wrong directory. Okay, so that is installed. So what I was trying to do last time okay, so that is all I was trying to do last time when I nuked everything. Is it Wednesday already? It is Wednesday, at least for another hour and a half. Okay. So, seeing as the lesson we learned was to get our code into version control, I guess that's exactly what I'll do. Although, I suppose we'll probably need a JIT ignore. And I guess, well, you know what? I have bookmarked what I want to do, I think. Let me just pull it up here. Where my stars at? It's like git ignore or something. Yeah, we'll just grab GitHub's git ignore. So what do we got? Python's in here somewhere, right? That seems a little excessive. So what do we have in source? So I guess we'll halfway do this. I don't know, perhaps I'm just so we want to include cache. And I guess we want to include that virtual environment directory. And I guess oops. Too much crap going on here. And I guess we want to do this egg info. So I'll just grab that. Boy, look at all this stuff. All right. All right. Looks good to me. All right. So now back at it. So I guess what I want to do is, so this is where all my stuff started from before. I just want to kind of start throwing things in here and then printing out what we get. So this is going to be guess we'll just stick with what we were doing before. I guess for now we'll just say, because I'm not quite sure yet what I'm going to return, let's just print the line. So now if I try and do anything, we should get a horrible... Yeah, that's exactly what we were expecting. I wasn't expecting my chair to flip out on me, but there you go. So I guess, you know what? I'll just delete that. So, and I suppose what I'm saying is, where's, because I guess we're going to be bona fide about this. Got to stick the license information in there. All right. Let's just keep the theme going here. So now, there we go. Progress. Okay. So I guess what we're gonna end up doing is our famous input iterator here. We're gonna have the I guess I guess I'll call this actually the TOML iterator. So that's what we'll do. So the first thing we'll do is we'll get our iterator. And then, so we're going to return, well, since this is the Lexer, we're going to return a list of tokens. And so this is where this grammar comes into place. So and I was actually thinking about this earlier before I nuked everything. The file does not need to end in a new line. So I guess what we really want is something like we're going to want to lex the expression. We'll give it the iterator and the tokens. Now, well, let's just do that for now. So an expression is a white space or a comment or a key val or a table. So we're going to want to take a look at the character. Well, actually, I guess the first thing we want to do is we want to eat all the white space. Pass in the iterator for that. Then we want to take a peek at that character. So character equals this. We're going to want to lex a table. I guess, right, one thing we can do is, so our options here, well, I don't know. So this is where I was kind of getting wrapped around the hub a little bit before. But right now, I guess we'll just assume everything's correct. Anyway, so the other option here, I guess, is we just hit a new line. Or the end of file. And I think I'm going to need my ASCII table for this. I'm not mistaken. So new line can either just be this new line or it can be a Windows carriage return. So let's check this. If we're at the end of the file, we don't do anything. New line or a does it return? I think it's that, right? What's this have to say about anything? Yeah, carriage return. Actually, I guess for all of this, we don't want to do anything. Oops. Oh boy, what am I? What did I do? We'll pass, otherwise we're going to need to alex a key valve pair, I believe is our option, yeah. Okay, so that is what that looks like. So what I'm thinking here is So part of this is I know what's happening ahead of time because I wrote most of this already. But I guess for now what we'll do is we'll do this. While we're parsing, we're going to want a lex expression, and then parsing is going to be eat new line. Because we'll probably need the iterator in there. And then we'll return these tokens. So that's kind of where we're at. Now, if I try and run this again, we... oh, yes. We should break horribly. That's not where I was expecting to break, but... Okay, so what we want to do, white space is either a tab, I think we probably want to return a Boolean here, but whatever. For now, we'll just and actually what we'll do is while and our options here are a space or a tab, we want to keep that character. Basically all that's going to be. Now we need to do peak character. There's that. We also want to eat character. So I guess here we'll assert that it's less than the length, and we'll just do, oops, that's right, iterator dot pos plus equals 1, and then we'll return, I think, well, we'll just do that for now. I think we probably are going to want to return like the next character. Now I got to eat this comment. So you want to eat the comment character. So I think what I want to do is I want to like have an assertion here that that is the character. Like, so we checked here that this character is the comment starter, and so here I basically want to assert that we're doing that. And that this is why I'm saying want to return the next character, I suppose. Actually, we don't. So basically, what's a comment? It's a start symbol and then this stuff. So basically, it is a non-end of line. Um, I'm just trying to think, so where is the new line? What would be nice to do is like peek this. So let's just peek that. So it's either going to be that, right? I guess because this is Python, I'm going to need to do something like that. That. Um, oops. Actually, I guess we don't even need to set that. So either the current character is a new line, or the character is a carriage return, and the next character is whatever they call it, new line. So in that case, we're going to have to do that. So so I guess again we're going to want to assert here that let's assert that. Then what we want to do is we want to say if that the length minus the position is greater than the position we were given, and I suppose I should, then we want to grab whatever the character is and return it. Otherwise, we'll just end up returning the empty string. So where are we here? We are on eComment. Jeez. See, we now, in theory, we could just seed everything, but according to this, we can't actually just seed everything. So, but even still, we're probably just going to want to eat, oh, yeah. Wait a second. What's going on? Oh, eCar. Oh, that's right. I wanted to, so we want to advance that. We want to say, then we want to either assert car is none, or car equals the result, and then we'll return the result here, I guess. So I did that. So we're already having problems. So 57, we count here through 41. Hmm. Well, I'm not quite sure how to do this with the module. I just do this again. Oh, yeah. We need to peek before we eat. So we need to either assert that as none or so I guess we still have no need to really return anything here. Oops. Okay. So except still having typing issues. So we want to eat this new line. I don't know. I feel like I move this. It doesn't really matter. So now we want to eat. So if that's going to be true, otherwise if oops. So now we're going to need this eat characters. Let's just do that. All right, so now we're here to Lex Keyval. And so I guess what we'll do. We're gonna need the tokens because we're gonna start shoving tokens onto there. So we're gonna want Alexa key. Then we're gonna want to eat a separator, and then we're gonna want to Lex value. That's kind of what we're gonna want to do there. But for now, what do I want to do? Well, actually, then we're also going to want to eat, right? We're going to want to eat white space, and then we're going to want to eat a comment, if applicable. We're also going to want to do the same thing with flex table, so maybe I'd just do that right away. Let's just do that for now. And actually, let's just do... we won't worry about that at the moment. But just to kind of see if this is working, what do I want to do? Basically, we can eat characters up until... what? Up until a comment. I guess we'll just do... let's just make token a string for the moment. Yeah, let's just peek that, because it's just temporary. Now I'm getting confused. Okay, so... let's just see what that gives us. We get an assertion error. Oh. Yeah, okay, that makes sense. That's going to turn into that, I suppose. Oh, we need to, so we should just get, well, uh, so why is that empty? Oh, and, so our fail condition is if that, or that, right? And we want not that. Okay. Boy. Okay, so we're eating comments. Sweet. And actually, I guess and let's actually just print just something here. Okay. Oh, well, yeah. Yep. Yep. Okay. All right. So now we've got to parse a key, and or Lexa key. So we want to lex this key. Oops. So it can either be a simple key, which is a quoted key, or an unquoted key, or a dotted key, which is a simple key plus a period and another simple key. So what do we say? A simple key is a quoted key or a dotted key. So we'll just do that. And then what did we say? Um, Fish. We basically want to look for this. Then what we want to do is we want to make a new token. This is going to be a token type, I guess, period, and we'll put the period in there. And then we're going to want to lex another simple key. It's kind of what that's going to look like. So then the simple key, what did we say that was? It was a quoted key or an unquoted key? So quoted key is a basic string, which is a quotation mark or a literal string, which is an apostrophe. So we want to lex a basic string. Now here things get a little weird. Because even though this is a string, we're doing it in a key context, so we want to actually get the string back and then make that a key token. So This is going to be a and I guess the result. Oh no, this is a literal string, right? No, wait, that's a basic string. No, I did the same thing. Literal string, same thing here. Else, we're gonna want to lex and encoded key. I think in this case we will just pass the tokens in because this is the only context in which we can have like an unquoted value. So let's just see where that gets us. We're in unquoted key. All right, where are we here? Unquoted key. Is, well, any of those. So, just do that. Well, kind of want to say is identical. We'll just call this, well, is. Let's call this is key character, and then let's just peek the character. Actually, here's what we'll do. Peek the character if it's a key character, then we'll tack that onto the key. Otherwise, we'll just set parsing equals. We also want to eat that. Now, this cannot be an empty thing, so this will be the key. Else, let's just assert false for now. Yeah, we got to do is key character. Let's just. Oh no, we're just taking the car, and then what were options here? Python, I can do this. And actually, oops. So it's that. right? So alpha, A to Z, A to Z, 0 to 9. Where are we here? Or dash or underscore. Oops. Okay. Now I gotta start defining some of this stuff. So, actually, you know what? Since this is our API, we'll stick that up there. So, what are we taking? We're taking the type and the value. And what we'll do is we'll just throw in a repr here. Oops. Just do that, and then we'll return that. So we also need, that's gonna come from enum, and we want this to be unique, and guess this is in the library. Oops. So what is it? Next value or something, or auto? Unique and auto. All right. So I guess we're gonna need to do that for now. Enum.key. So we need key. Went too far there. Oh, ecar white space, yeah. So eat white space. Result's gonna be false. Eat white space. Then result's gonna equal true, and then we're gonna wanna eat more white space. Uh-oh. The Linux huge page daemon has kicked in for no good reason. All right, so what do we get? Oh, That's right, we're only doing keys. So we have key, right? And we have another. So now we want to no, we want to eat white space character. Or ecar, what do we say? Ecar white space. The equal sign here, right? Where's my grammar? That separator, right? We have that in Lex key, ecar white space, and then our separator, yeah. Then we want to that's what we want to do there. Why do we think that's the case? Um, so 44. This is the comment at the end of a line. So why? It's in tokens. Huh? Oh, what am I doing? Wait a second. Oh, Lex key. Oh, okay. So that was what I was expecting. Okay, so we have I feel like we should not have that equal there anymore. Is oh, we need to eat that character. Right, so now, yeah, we'll just have that left. So now we need to, let's say, okay, well, we'll put that here under, we'll put that down here. Now, this is where things start to get a little crazy, because value can be pretty much anything. Um, yeah. So how do I want to do that? Because I'd kind of like to finish off. Well, you know what? Let's do that. Let's so what have we got? We've got white space taken care of. New lines are taken care of. Comments are kind of taken care of. We've got unquoted keys. So let's take care of these strings maybe, right? And with these examples that we have, that'll actually take care of us. So what did we have? We have oh, flex like a basic string. Yeah, so we'll put this under value. Don't know why I did that. So we want to, in this case, we do want to eat a character, and a basic string is what? I think the double quotes. Is this really going to there's been something going on my Linux lately where this huge page daemon just fires up and like pegs my CPU, and I don't really know what is causing it. But my water glass is empty, so I am going to actually take a beverage, turn up the fan here, and take a beverage break. So for about 3 minutes, I guess. And then we'll finish, well, at the very least, we'll finish parsing out these keys. Oh, I don't know. We'll see how far we get. But yeah, I'll be back, I guess, in a few minutes. Well, I don't know. I'm just looking at huge page daemon hogging up my CPU. All right, so what are we doing here? We're parsing basic strings. So basic string is a quotation mark with any number, including none of basic characters, and a quotation mark. So now the only way we got here is because we peaked this quotation mark. So I guess we'll just stick with this. You know what? This should not be parsing. This should be lexing. So what are our basic characters here? A basic unescaped, which is a white space character. So I guess here's what we'll do. We'll pick this character. And then if the character, right, if we hit our thing, we are we want to eat it. Or no, I guess we don't. We want to and actually, right, we could run out here. So let's try that. If we get the empty string back, then we're lexing. What other options here? It's an escape character. Then we want to lex and escape. Figure that out when we get to it. Otherwise, it's any one of these. So maybe let's just do that. We're going to have our string here. We're going to want to so it can either be, so white space character is 20 or not 20 or 9. Where are we here? So here, let's just do this. If so we want to be greater than 20. So now 22 though, right, is, oh, it's a quotation mark. So we've already captured that in our condition. So, and then what is 5C? 5C is the escape, which again, we've already, where are we up here? We've already gotten that. So basically, we are straight on to straight through to 7E. Now we need to see what these non-ASCIIs are. Right, so 20 is the space. Okay, so non-ASCII is that's basically all we need to do there. Let me just check these numbers. So 80 to D7FF. Or E00010 FFFF. Okay. So where are we calling this from? So I guess what we can do is, you know what, instead of this, let's do that. Let's put this down here. Let's do that. And so now should have well, we need to handle escapes, but we're not quite there yet. But now we just need to return this result. And where are we calling this for? Oh, from Lex. Yeah. Okay. Ooh. Guess we'll just pass that for now. That's right, we're not lexing values yet. Okay, so now I think that is everything for, oh, well, we gotta handle escapes. We'll get there, we'll get there. And then we have what, literals? A quoted key is a literal string. Where's literal string? Literal string is an apostrophe, so basically the same kind of thing, right? Yeah. So here's what I'm going to do. I am going to pass in whatever the separator or the delimiter is here. So we'll do that if it's, and actually let's assert that let's assert that and we'll eat that delimiter. Now the literal string, we basically don't have any escape characters. And we can, it's the same logic. So that is what that turns into. And now I believe we can, at least for now, we can parse Lex's value. So I think now we'll be parsing our most basic example. Yeah, return. I called the string, didn't I? So I feel like that's not right. We are not parsing. So let's, I guess. So I want to break on Lexer 17, I guess. So we should be at 0 here. So let's just go next. Oh, that's right. We are, right, we ate that new line. So now we're going to eat that. So we got that. So now I feel like oh, wait a minute. Did I told keep forgetting to eat my dang characters. All right. So there we go. And actually I guess I was I don't think we want to eat those new lines, do we? Since they're actually statement separate or expression separators. I guess for now, we can always not save them. So what have we got? Eat, new line. We want to lex that. So what we'll do here is and I guess we want tokens. So if result, then we want to new line, and that'll just be that. Okay, and now we're going to need to stick this token in here. Okay, so now here in main, what we can actually do is oh, what is our built-in functions here? Print end equals just want to set that. So now if we start printing stuff out, we get that. Is that, are we getting an empty? Oh yeah, we are getting that right, because there's this empty, this just boils down to one new line. So yeah. And I guess what we can do is whatever, that's fine. I don't care. Okay, so that takes care of that. So now we have key value pairs. All right, the huge page demon finally stopped. I can turn my fan down. So we'll do key equals. Now we should be able to handle this already. Right, yeah. Unspecified values are invalid. So And this is invalid. So I'm not quite sure what's going to happen there. So Alexa, I guess, kind of needs to capture that, or not capture it, but catch it. So I think one of the things my Alexa was doing before was it was being a little bit too generous. So what are we doing here? We've got so I guess what we can do, right? We have a check here, right? This key character. So what we'll do is this is kind of like a do loop where we want to keep that. And actually, let's just assert so then we're going to want to eat character, and I now need to check boy, I got a bunch of white spaces in here, don't I? Just take some of that out. It's a little gratuitous. So right, that eats the current character, gives us back the next one. So then what we want to do is this is key. Invalid missing key. So that's still not going to get us. It's a problem here. Oh, I see what's going on there. I missed that. So this is going to be a little hard to do with the value because we've got all these other values we need to handle. But at the end of the day, we're going to get down here. Right, so that's just gonna blurb there. But so, oops, we can't do that actually, because it doesn't matter if our parse is working, right? So where does that bring us? Right, we get a value. Um, right, we get Tom. So we're back here, and we eat the white space. Oh, we just stop, I bet. Hey, Bazin, how are you? How have you been? Last time I saw you, or I saw from you, you were on your way out the door. I suppose I'm probably sliding off my camera here. I feel like I need to do a... Okay. So I think, oh, no worries. Yeah, I know, this is, bad time for you. I'm doing okay. I've been a little sick the last couple days, and today was pretty much a sick day for me. But other than that, I'm doing all right. I deleted all my code earlier. I think the last time you were in here, I was working on this, and I deleted it earlier. Unintentionally, but I'm doing all right, I guess. How's school going for you? Right, you're off to school? So, basically, well, it was the sort of thing I didn't have it in version control, and so I was just being nonchalant about what I was doing. Because the first thing I said is like, "Well, this is why we're in version control," and I was like, "Wait a minute, I'm not." But oh, nice. It's always good to have those over. And I suppose we're gonna want to like resync this. Nice. Yeah, I still have that sitting around. Um, and I hadn't forgotten about it. I just work has kind of pulled me away from streaming, so I'm kind of trying to do it a little bit more for various reasons. I guess I must enjoy it. But yeah, maybe one of these days I can still go over that with you if you want. Do like a code review on stream or something. Oh, nice. Well, one thing I remember looking at it was you were doing a right. You were writing stuff to like a file and reading it back in, and you were kind of using your own format. And I was going to suggest uh, just doing like a CVS parser. Like if you just Wikipedia throw that into Wikipedia. Oh, okay. Well, that works too. Well, right, because if you're doing Python, you could probably just use the built right. Doesn't Python have a built-in like to JSON or JSON encoder? So since you're writing it by hand, I was thinking just do a CVS like parser because that's pretty simple to do, and you can see like how it handles escape characters and stuff. Because I noticed you had like you can't use this character in your file because you were using it as like a separator, so you could kind of see. Um, I mean, CSV isn't really standardized, but there's ways to do that. But that was just kind of my thought. But you've moved on since then. So I think now, yeah. Okay. So we're at least catching these, I guess. We're not going to just want to crash horribly. We're going to be a little bit more intelligent about it. All right, have a good day. Thanks for saying hi. I guess I'll catch you around later whenever I'm streaming and you're not on your way to school. All right, so now we want to do. Oh, okay. Nice. All right, talk to you later, Basin. Have a good day. Well, let's just start working through, right? We have bare keys, dotted keys. So we've already got this. That's allowed too. So I think we should be handling those. Let's see what we get. Equals value, bare key, bare key, bare key. All right. Quoted keys. So we've got, oops. That's another thing I'm going to have to just copy and paste. We've also got, oops, key2, and so that appears to be working. So let's see here. Or empty, was it? Empty. Not sure about this, all these comments about valid but discouraged. Like if you're gonna make it part of the language, don't judge people, you know what I'm saying? So, and I believe that is coming from there. Okay. Where was that? There. Okay. Dope. So we're handling that. Now I've got dotted keys. What do we have here? Name equals orange. Physical.color equals orange. Physical.shape equals round. And site.google.com is true. Uh-oh. All right, well. Period. Ooh, we don't have a period. LMNOP. So 140, that's going to be on true, I bet, right? Let's, oh, car. So it should be barfing on the T there. Yeah. Um, so maybe we just handle that here. Actually, here's what we'll do. We'll do can't remember. I guess this is going to be Boolean and this is going to be true. Let's throw bool into here. We need to implement that each where are we here? Huh? Oh. Wait, what's going on here? Oh, I need to close those. That's what's going on. Okay, each string. Cars, oops. Comment. Actually, this needs to go up here. Just, I don't know, put that up there, I guess. Uh-oh, the huge page demon is back. Oops. Um, Boy, it's nasty out there. So for here's what we'll do. We'll grab the string length. I think that'll work. So why did that not work? Seems like that should have worked. I guess we may need to. Let's go to 230 here. So it's true. Okay. Four, right? So 1, 2. So that's T. Okay. Oh, my peak character is not working. This is, let's pause. Let's try that. Let's give that a shot. Um, and that's going to be cars anyway. Okay. So we are getting that back. So we can just do banana. So I think we should be okay there. Yeah. This is invalid. But where our Lexer is multiple, our Lexer is not going to catch this, I believe. Do not do this. Add and we'll just got anything else in here? Yeah, so that lexes, but it should not parse. Um, um, so I think that will parse. Oops. Apple fruit smooth. It's true. New line. So something's not happy there. Oh, you know what? Two, because we're not doing integers. Uh, let's not worry about this for now. Okay. So what is this? Redefining fruit. make that apple equals 1. Now this will probably Lex. Yeah, that Lex is. And and then I'll parse, yep, or Lex, I should say. And let's stick this into where we have dotted keys. So, all right. All right, does that... Okay, now we're on the strings. Let's see here. Time is it? I need to keep an eye on the time. Stuff starts to get fairly gnarly. So I'll probably get through strings. Booleans are done. But integers, floats, and date times all sort of end up running together. We're gonna have to what are we doing here? We're doing basic string. That's gonna explode on us, I believe. Because we have these escape characters that we're not handling. Yep. So let me just though make sure string equals I'm a string. You can quote me, name, this hoobie. All right. So I guess we need to figure out what we want to do with this. I think we just need the iterator for this. These are all the so I think what we want to do is where are our escape quote characters? So uh I'm just gonna do that. No, you know what? We'll just set this to the car, I guess. Form feed. Oh, is it a small u? You know, in all these cases, we're going to want to eat these characters. Oops. And that's 8 Unicode characters? Yeah. Um, I guess what we'll do is this is invalid. What we'll do is return just an empty character. So now we're gonna need this. All right, so I guess we'll do the same thing. Result is going to be this empty string, which we're going to return the result, and then so we'll have here's what we'll do. We'll do digits equals that, valid equals true. Just sort out the result down here. It is hex digit peak. We want I. I guess we'll do digits. Then we'll break if valid. If valid, then what we'll do is we'll do and we're going to need to look up. This is what do we say this was a hex digit? So this is going to be int here with a base. So we'll do that. But then we want to actually we want to eat those characters. Yeah. Yeah. All right, so I think that might actually work. So we're calling Lex escape now. So it's gonna give us that, I guess. Extra garbage. We shouldn't be having extra garbage. Oh, you know what? Because I literally just said that. We want to eat all of these. Oh, yeah, that's hex digit. Where are we at? Hex digits. Show me where you're at. All right. String object is not callable. Oh, car. Yeah. Wow, that looks, is that really what that's supposed to look like? I'm a string. You can quote me. Name Jose. Well, all right. If and you say so. If and you say so. All right, now multi-line. So I think we kind of already got that handled, but thinking about sneezing. I think I'm done sneezing. I think it's time for another water break. Maybe a might be time for a cookie or something too. Although I'm running disturbingly low on leftover holiday cookies. But they're there to be eaten, so I might as well eat them if I have them, huh? Yeah, I think I'll get through these strings because I have a feeling, having done this before, once I knock out multi-line basic strings, I'll basically also have multi-line literal strings done. And then I'll just skip down here to the Booleans, I suppose. Make sure that's all that is looking solid. And that'll leave me with numbers and stuff later. Okay, so where are we here? Oh yeah, I'm getting water. Okay. So I'll be back in a few minutes with water and maybe a cookie. See what happens. All right. On to these strings. Surrounded by 3 quotation marks on each side and allow new lines. A new line immediately following the opening delimiter will be trimmed. Okay. Examples. So multi-line literals. A new line immediately following the opening delimiter will be trimmed. So that will be trimmed. But that not, I guess, is what it's saying. So yeah, I think well, I guess what we want to do is that's our only basic string, I guess so. So string 1 equals roses are red, violets are blue. So what's going to happen? We got extra garbage. We got extra garbage. This is now what we want. So where Lex value. So peak car. And string, we're gonna Lex a multi-line string. Otherwise, then we'll just append. We'll make a string out of that. So for now, I guess I'll just yank this. Gonna want to eat 3 of those. Which means I think I'm gonna have to update my do that. So string equals that, lexin equals true. So we're going to need to do well, let's pull my grammar up here. Raise where are we? Multi-line basic string. So our multi-line basic string delimiter. Where are you? 3 quotation marks. Let's eat a new line. What happens here? Oh. Well, okay. I think what I want to do is kind of split this out. So what do we have? Eat new line. So up here, if eat new line. If we do that, then we'll just shove that new line in there. And return it. Uh-oh. Multi-line string. Okay. So then we eat that new line. Oh. Hey, Real MKB. Yeah, I agree with you. Yeah. The only reason I'm writing this in Python is I'm working at Python at work because I'm probably going to rewrite this in C++ because we're also using C++. And we have tools in both languages parsing TOML files. So yeah. Well, I don't know if the Lex would be any simpler because, right, the TOML file you're reading in is just text, right? I don't know. But how you doing? All right, so we get an optional new line, we get this body, and we get this delimiter. So it's optional content plus oh, okay, I see. So our MLB content is what? An MLB character or a new line or MLB escaped new line. An MLB unescaped or escaped. So escaped is already up here, I feel like. Yeah, escaped is here. So we're already handling escape here. All right, so MLB character. MLB and escape. So that is, I think, so it's a white space character, which is 9 and 20, right? Yep, 9 and 20. 21, then 22 is what? Quotation mark? Yeah, and then 5C is, oh, what? That. So this is just going to go to our string character. Or it can be a new line. So I guess what we'll do here is I'm doing all right. Work's keeping me busy, so I haven't been streaming much, but I've kind of been working on this TOML parser. It's sort of just a side project a little bit, kind of related to work. I'm feeling a little sick lately. In fact, today was kind of a sick day, so I decided to hop on and get some work done. Of course, I was streaming a little earlier and I deleted all my code, so I had to restart from scratch on this. So there you go. It hasn't been such a great day, I guess. But I guess any day you can complain about. Can't be all too bad, huh? I don't know. Yeah, it's just like a configuration file language, I guess. We're using it at work. Uh, so if we eat a new line, we have a new line, right? Or we have an escaped MLB escape new line. So it can be escape, which escape is just the escape character, right? So I guess what we want to do here, right? We can either have one of these or this situation here. So escape, Lex escape, Lex escape can't actually itself report an error. Um, Although we can. Hmm. Well, let's just assert for now. I know we're gonna have to figure out. But essentially valid's going to equal false. But so here's the thing. Here's what I was saying, right? We have an escape character here, right? And then we look at our options, and if it's nothing, well, we don't hit one of our options. We basically flag an error here. But we can't really do that here because we also have this or Well, we could handle this a little bit differently, I suppose. I think this is actually okay. So what we'll do here is, so if we get it, so first of all, this works. What are we doing with eat white space? So let's do that. Let's spell result correctly there. So if eat white space, then otherwise we'll do that. So I think we're fine there. Then eat a new line. So what are we saying here? Then we can eat any number. Eating equals eating, then while eating, we're gonna eat white space, and we're going to eating equals eat a new line. Otherwise, oops, this is going to be an invalid escape. So I think that handles that. So yeah, now we need to sort out these quotes. So I equals 1. Well, and so that's what we're going to want to do there. We're going to want to eat then I number of characters. And if so if I equals 1, I think we just delimiter, right? Gonna do that. If I equals 3, Lexine is gonna be false. I equals 4. This is all going to be true, but we're also going to start eating stuff too. So I think that. So let me just right, this all gets eaten here, I believe. Yeah. So let's just see what happens, if anything. Roses are red, violets are blue. Okay. So that is surprisingly working. So let's just add this to our example here. As, oops, well that was obviously not what I wanted to do. Strings, string 2 equals roses are red, violets are blue. This is going to be that. On a Windows system, the above multi. Oh. Mildly curious how that's going to come out. Okay. So now we want well, so what is this? A line ending backslash. So here we go. Equivalent. Okay. String 1 equals quick brown fox jumps over the lazy dog. This is quick brown X jumps over the lazy dog. String 3 is going to be quick brown fox jumps over The lazy dog. Let us see what we get there. We get an invalid escape. Why is that? Did I mess that up? Well, let's see how we got there. So which one are we hitting? We're hitting that. Because, and why are we hitting that? Oh, white space. Um, where are we here? So like I think we have peak new line. Yeah, we do. If where are we here? So if eat white space or peak new line, I think that's what we want. That did nothing for us. Uh, 148. So let's figure out um so somewhere we are so let's see what's going on, I guess. I guess we'll stop at 200 there. So we got the um so this is probably not a great place to break. Let's clear that one, but let's break on let's break there. So what do we have for string? The quick brown, okay. Oh, I see what the problem is, right? We need to right, we have an advanced past that escape character. Uh So maybe we don't. I guess one way we can handle that also means where else are we doing this? So we're going to need to get rid of that there. And we're going to need to do that there. Okay. All right. Um, so now we should be looking good there. Okay. Let's mess around with quotation marks. Multi-line quotation marks. Uh, then we have string 5 equals, here are 3 quotation marks. String 6 equals, here are 15. Quotation marks. Okay. This is getting a little so oops. Well, that's not what I wanted to do. So I guess we got that. As obnoxious as that was. Ugh. Hit some code path we hadn't hit before. Yeah, I guess we do need, oops. Here are 2 quotation marks, simple enough. Here are 3. Here are 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. All right. So now we are onto literal strings, which I think we already have. What you see is what you get. Wind path equals C. I guess I have to escape that. Wind path 2. Oh. Server X, admin, system 32. Quoted. Tom Dubs. Preston Werner. Regex. C users. Is that what's supposed to be? Yes. Okay. And multi-line literal strings. Regex2 equals need 2 apples. Let's just change all this out. Oh, I did not necessarily mean to delete all that, so but let's oops. For the moment, let's just comment this out. I don't need 2 apples. The first new line is trimmed on. That looks correct. I guess we would have that double white space because that has a white space or a new line. So just need to right, 1, 2. Well, I can do with that later. You know what I'm doing? Where did I leave off? I'm done typing all this in. Especially because this is the second time I've done this. That is invalid. But this is valid. Um, Anything I need to escape in there? I guess not. What do we get? What do we get? What do we get? That's what we get. Okay. So where does that leave us? That leaves us with... Oh, I was gonna do bools real quick because I think bools are done. Uh, Boolean values. Bool1 equals true. Equal 2 equals false. So assuming this works as expected. Oh. Oh yeah, that's right, that's right. Okay, well, now I've got all this stuff to do, which is fairly nasty. But I don't know. I guess I'll do that for another day. I brought this cookie over. I didn't eat it, but I guess I'll eat it off stream. So, real MKB, if you're still lurking there, then thanks for stopping in. But I'm going to wrap things up. If anybody else is lurking, appreciate you hanging out. But I'm going to call it a stream. Probably call it a night, too. So until next time, I bid you all peace and take care of yourself. See ya.